Hi, in this video we're going to explore the powers of the imaginary number I. Now we know that the definition of I is that I is equal to the square root of -1. So let's explore some of the powers. Powers just means exponents of I. So here the first one, I to the first power is just I. In the second one, I square, you have to multiply I with I. So you get I times I squared is equal to I times I, so you get square root of -1, you have to square it. So the square root and the square cancels and you just get -1. I to the third power, you get I to the third power by multiplying I squared times I. So we just found out from the previous one that I squared is nothing but -1 times I, so it's -I. So we got this answer as -I. Now I to the fourth power is I squared times I squared. And from the one over here, we can know that I squared is -1. So we are multiplying a -1 times a -1. So we get our answer as 1. So I did the first 4 over here. So these are the first 4 answers. Now let's just do the next set. Okay, now I'm going to do I to the fifth power. So to get I to the fifth, I can take I to the fourth and multiply it with I. I can factor it like that. Why did I do this way? Because I know the answer to I to the fourth is equal to 1. So I can put 1 times I. My answer is just I. So this answer becomes I. How do I find I to the sixth? I can take I fourth times I squared. So when I do that, I know I fourth is 1, I to the fourth power is 1, and I squared is nothing. From the first column, we find out that I squared is just -1. So 1 times -1, my answer is -1. Okay. Now I to the seventh power, again, I can do I to the fourth times I to the third. I to the fourth is 1. I to the third from the previous column is -I. So when you multiply 1 times -I, you get -I. So again, I get a -I here. The last one, I to the eighth, I can factor that as I4 times I4, I to the fourth times I4 to the fourth. So when we multiply, we know this is just 1 times 1. My answer is again 1. So similarly, if we continue this, I to the ninth, I can write factor I to the ninth as I8 times I1. So I8, I have the answer from the previous one. It is just 1 times I. My answer becomes again I. So I get my answer as I. Then for I10, I can write it as I to the 8th power times I to the 2nd power. And I8 is just 1 again. And I to the 2nd power is -1. So I get my answer as -1. I to the 11th, we get I to the 8th times I to the 3rd. That's how I can factor that. I to the 8th again is 1, and we know that I to the 3rd power is -I. So I get my answer as -I here. So this answer is -I. And the last one, I to the 12th, can be written as I to the 8th times I to the 4th. And we know I to the 8th is 1, and I to the 4th is also 1, so it's just 1 times 1. My answer is 1. So we could keep on going like this, but I just did the first 12 powers of I so that you can see and check if there is a pattern going on over here. So if you look everywhere here in my first row, my answer was I. You can see a pattern repeating here. In the second row, it's -1. In the third row, it's -I. In the fourth row, it is just 1. So this pattern is repeating. You get I -1, -I 1. Then the answer goes back to I -1, -I 1. Same thing happens again. I -1, -I 1. So when this happens, when there is a pattern for the answers, we can always make a conclusion and make a rule out of it. So if you see here, if you check the exponents, let's start from the last row here. All those numbers, the exponents, are all multiples of 4. See, 4, 8, 12. That's like 4 times 1, 4 times 2, 4 times 3. So we see that when the exponents are multiples of 4, your answers become 1. That means if you take these exponents, if you want to talk about like a rule, if you take the exponents and you are trying to divide it by 4, it'll completely divide. It will be a factor of 4. Okay? Or in other words, the remainder will come out to be 0. So when you divide by 4, when the remainder becomes 0, you get your answer as 1. Okay? Now in the third one, that's this one. Let's check this row here. I to the third, I to the 7th, I to the 11th. If you look at them, when you divide by 4, your remainder becomes 3. Right? They're not multiples of 4, but the remainder becomes 3. So when the remainder is 3, if you have an exponent and you're trying to divide it by 4, if you have an exponent and trying to divide it by 4, and you get the remainder is 3, your answer is negative I. Same thing if you take the exponent and if you divide it by 4, but you get your remainder as 2, your answer becomes the second row here, negative 1. And if you take your exponent and divide by 4, you get the remainder as 1, your answer becomes the first row here, which is I. Now why are we dividing by 4? Because when we check this, we see that after every 4, the pattern repeats itself. See? 1, 2, 3, 4. You got 4 different answers, and then the same pattern repeats again. 1, 2, 3, 4. That's why we are trying to divide by the exponents by 4 to see where will it fall. For example, I'm going to clear this exponents on the side so I can have some space to write. So let's try an example. So if you have I to the 29th power, okay? So I will take my exponent 29 and I will divide it by 4. I know that 4 times 7 is 28 and I get my remainder as 1. R is my remainder. So we know that if you get the remainder as 1, your answer has to be I. So it'll fall under this first row. So I will get my answer, my final answer is equal to I. Because when I divided the exponent by 4, I got my answer as, my remainder as 1. So let's just talk about the conclusion part here. When dividing the exponents by 4, when dividing the exponent by 4 and getting the remainder is 0, then you can say that your answer for I is equal to 1. I to any the answer will be 1. I don't want to put I equals 1. So your answer will be 1. If the remainder is 1, if the remainder is 1, your answer will be I. If the remainder is 2, the answer will be negative 1. If the remainder is 3, the answer will be negative I. So this is the pattern that we have. Okay. So let's just do a few examples here. Just put this up over here. I to the 17th. So we take 17 and we divide it by 4. And we know that 4 times 4 is 16. The remainder is 1. Okay. And the remainder is 1. Your answer is I. You can always write it on the side, a small box. When the remainder is 1, the answer is equal to I. And the remainder is 2. The answer is equal to negative 1. The remainder is 3. The answer is equal to negative I. The remainder is 4. The answer is equal to 1. You can always write it on the side when you do problems like this. Again, when you take 51 and you're trying to divide it by 4, you know that 4 goes into 5 1 times, bring down the 1, 4 times 2 is 8, 9, 10, 11. So your remainder here is 3. So if your remainder is 3, your answer will be negative I. Again, you have your next exponent 402 divided by 4. 4 goes into 4 or 200 times, I can just put 400 here. I got my remainder as 2. So my answer is -1. And 144 divided by 4. 4 times 3 is 12. Remainder 2. Bring down the 4. 6 times 4 is 24. So that it is a multiple of 4. It goes completely. And your remainder is 0. So your answer, this is actually not remainder 4. I'm sorry. This should be remainder 0. So if your remainder is 0, your answer is 1. I meant to say this is a multiple of 4. So that's how you get the remainder as 0. Let me just write that properly over there. So if your remainder is 0, your answer will always be 1. So this, no matter what or how big a power of I you pick, you will get one of these 4 answers only. You will not get another answer different from these 4. So there's a pattern for the powers of I, and they go by what do you get when you divide the exponents by 4, and what remainders do you get, and you can make a rule based on that.